Over the past 7 years, specifically since 2018, the Building Practice as a company has been involved in designing, coordinating, and putting together high-rise buildings. But before I go further, I would like to let you know what a high-rise building is. By definition, according to the International Building Code, a high-rise building is a building that has occupiable floors and spaces at 75 feet, which is equivalent to 22.86 meters above the ground level or the fire access level. And in these past 7 years, we've had the opportunity of working on about 11 to 12 high-rises, namely Sapphire Tower, which we got on in 2018. And from there, we moved on to 27 Global Road, which is a 15-story building with a basement. Sapphire Tower it's 19 floors. We worked on Molina office building, which is 10 floors. We've worked on Peace Tower, which is 26 floors. Oculus Grande, which is 37 floors and 2 basements. Mandela's Towers, which is 17 floors. We've worked on Jetty Towers, which is 30 floors. We've worked on Parkview Residences, it's 10 floors. We worked on Wuta Residences, it's 13 floors. We worked on Plot A4 Residences in Banana Island, which is also 13 floors. And on all these buildings that we have worked on, we have gathered a lot of experience over the years because they all come with their various challenges. And in designing a high-rise building, the experience comes from various factors, which include facade, which includes the mechanical and electrical considerations that you have to make as an architect. It includes the peculiar site considerations. It includes energy efficiency that must be optimal at a very high level for buildings of this size. And the market demand as well, because in all our endeavors as a practice, we ensure that our buildings don't only satisfy aesthetical value, they also satisfy the client's business objectives. So in all the high-rises that we've worked for, whether it is commercial, whether it is residential, whether it is retail, we've taken into consideration all these factors that I mentioned earlier. And the experience has been very interesting, and we have seen that over the years, we've been getting better at it. With each high-rise that comes our way, we are able to incorporate better considerations and come up with better designs that meet internationally acceptable standards. And we are looking forward to even working on more high-rises. There are so many of them in the horizon because our economy is a very dynamic one that continues to call for more high-rise buildings, especially in the market for the high-end luxury real estate residential niche. And because of our experience, we've been able to meet the demands for this peculiar market. Our experience also has taught us that designing high-rise buildings is a very interesting part of architecture because it gives you the opportunity to do buildings of very, very strong legacies. The high-rise buildings are usually landmarks, and we've succeeded in the past 7 years in the various buildings that we have put together. We've succeeded in creating masterpieces, in my opinion. There are various zoning laws which have been put together by the Lagos State Fiscal Planning and Permit Authority concerning regulations for height restrictions for various locations in Lagos. And this also happens in various other cities in Nigeria. Particularly, I will zero it down to Lagos because that's where our practice originates from. In Ikoyi, for instance, there are certain parts of Ikoyi where there's a height restriction of 40 meters, meaning that in most cases we cannot go more than maybe 10, 11 or 12 floors. And in certain areas we have, on roads such as Bodilon Road, we're able to go as high as 110 meters. And in this location, we are able to have buildings that are about 29, 30, maximum of 30 floors. And we've taken advantage of these regulations to produce remarkable buildings. Buildings such as Jetty Tower, which is about 30 floors, and Peace Tower, which is 26 floors. We've tried to maximize the height restriction in these areas. For the area in Victoria Island, we have areas also that restrict us to 40 meters, 110 meters. In places like Eco Atlantic, we are able to go probably a little higher. But for now, the highest buildings that we have in these areas are maybe about 30-something floors. There's none of them that is up to 40 floors yet. But we hope that there will be a review of these regulations because times have changed. Technology is improving. Design progress is also being enhanced. And I believe that our environment is ripe for buildings a lot higher than 110 meters. There's nothing wrong in us being able to design buildings that are 40, 50 floors and move us from the stage of high-rise buildings to skyscrapers. And but for now, we keep within the regulations as stipulated by the various physical planning permit authorities in the various states that we operate in. There are various energy efficient measures and sustainable building practices that can be incorporated in the design of high-rise buildings. Due to the fact that high-rise buildings are very large structures, they have very huge masses, there's a high potential for energy loss. And if this is not taken into consideration, you find that these buildings have a lot of high carbon footprint to offer to the environment, which is very, very negative. And so it is incumbent on the architect and the design team as a whole to put into consideration various measures, such as ensuring that the facade, which is a very, very large, which usually has a very large surface area, is designed with materials and systems that ensure that there's energy conservation within the building. In this regard, we expect that our facades are designed with energy efficient glazing, low E glazing, and in most cases we use in building practice, we specify double glazing to ensure that as much energy is kept outside the building and not within the building. We are also very particular about conserving water because the ripple effect for conserving water also has an effect on energy consumption. And in buildings of these sizes, if you do not take into consideration minimizing the use of energy, you find that the operational cost of running these large structures and these large facilities becomes very, very high, and in some cases unbearable for even the facility management operators. So conserving energy in high-rise buildings is very essential, because if you do not conserve energy, especially through your facade, you find that your cooling load becomes very, very high. And once your cooling load is high, you have a high demand for air conditioning. And once your air conditioning is high, you have a high demand for energy. And we know our society, the society in which we live, energy is either very expensive or sometimes not even available, and you have to produce it. And we produce this energy through fossil fuels by burning diesel. So if you have a high demand for energy, then you require a high demand for diesel. And burning diesel, which is a fossil fuel, has a negative impact on the environment. We try to make our sites as sustainable as possible. In some cases, we've gone as far as recycling grey water, recycling storm water, just to be able to reduce the demand for water in these very large structures. And all these things put together ensure that we are able to produce buildings that are sustainable, buildings that are green. So at the building practice, our experience over the past 7 years, in my opinion, has been very remarkable. The fact that we are able to have designed and coordinated and put together 12 high-rise buildings in less than 7 years has built a lot of strength for us, a lot of capacity, a lot of knowledge, building and sharing, both locally and internationally. And on each of these projects, we've been able to incorporate various sustainable measures that have earned us certification on some of these high-rise buildings. And we are still pursuing certification for some of them, either through LEED or through EDGE. And we have positioned ourselves as a company of first choice for the design and delivery of high-rise buildings in Nigeria. And we believe that with the experience that we have gathered, we are in a position to design even bigger buildings. We hope that the regulations will change and enable us to move from the position of high-rise buildings to the position of skyscraper designers in Nigeria. With our efforts so far, we believe that we're able to stretch the regulations that have been set by our governments, because we have seen that high-rise buildings are possible to be designed and constructed in Nigeria. And we hope that with the efforts that we have put so far, there could be a shift from 110 meters to probably 500 meters to enable us to begin to design skyscrapers in our society. Skyscrapers that are both energy efficient, that are sustainable, that are functional, that promote the environment and enhance people's businesses. Thank you very much.
First of all, it depends on the complexity of the project, because the type of materials selected, the level of detailing that is required. But for an high-rise building, let's say averagely of about 20 floors, it will take us about, let's say, 10 to 12 months to be able to complete the design and documentation. And no matter how complex it is, I think within 18 months max, all the drawings should be ready. That is from the brief taken from the client to the concept designs, to the conceptual, to the design development, and to construction documentation, everything that is required. We can get that done in about 18 months at Building Practice. And this is minus the time it takes for approval, because sometimes, depending on the complexity and the documents that are being asked for by the government, it could take longer than that for approval to come out. So removing the approval period, let's say about 18 months. Then moving into construction itself, depending on how long the piling takes. But for a project like Pistol, I think the piling took about 6 months or thereabouts. So if you had 6 months for piling, then to the project construction itself, we'll be talking of about, let's say, 3 years. So with another, with that time put together for design development and all the drawings and documentation, let's say it takes averagely 4 to 5 years to actually be able to deliver a 20-floor buildings with the level of detailing that is required and what we do in Nigeria. For example, we have a project called Plot 4 at Banana Island. I think that's about 14 floors, and it took about maybe 3 to 4 years thereabouts. So depending on complexity and what is required and the budget available in terms of funds from the client, the speed of the project that is consistently funded from taking brief to delivering the project takes about, let's say, 4 to 5 years averagely. From our previous Edu series, there's a part where we talked about fire safety. And one of the ways to ensure people get out of buildings safely is to have a safe escape route. So in every building, not just only high-rise buildings, there's a part where in design you've already considered where people can escape through in case of fire. So in situations where you have a fire in an high-rise building, there is a safe path that you're supposed to use. Most times you see on buildings, they said, do not use lift, use the stairs. Most times, those staircases, they are called a fire escape route in the sense that there's a pressurization that is already, there's a pressurization system already installed to keep that staircase protected in case of fire. So from every space you are moving, there's a path that you're supposed to follow through, which, depending on the signages that are installed on the buildings, when there's a case of fire, there's an emergency route that you're supposed to take. And an emergency route in a building, according to the International Building Code, should be safe for at least 2 hours, such that fire can get into that space in case of fire for 2 hours. This is enough time for the fire safety authorities and the firemen to get into the buildings, and evacuation can be done. So there are things that are put in place such that that route, the door to be installed, has to have a fire rating that meets the required standard, which should be about 1.5 hours fire rating for a 2 hours fire compartment. So a safe route is a fire compartment such that you are safe from when, in case of fire, you can escape in the building through that route. So you see things like I mentioned earlier, do not use lift. In case of fire, people are advised not to use lift because of the volume of people, and even the electrical systems in the building can shut down depending on the type of fire prevention system that have been installed in the building. But the principal route that should be used in case of fire is what we call the fire escape route. That route is expected to be fire rated. The part that it leads to should be safe in case of fire till you get out of the building and all the way to where we call the muster point, where everyone is supposed to gather, and it's safe enough and far away enough from the building in case there are some fall-offs from the building in a time of fire. So that's principally what you do for people to be able to get out of the building. Okay, so what we try to do at Building Practice is we have a standard operating procedure, which we call the SOP. It captures everything that we do. We have the SOP for brief collection, we have the SOP for approval drawings, for design development, for construction documentation. Even on projects where we are doing architect of record, we have the SOP for that. So this has captured what is required and can be customized for every project. But this is like a base level document. These are base level documents that we use to control the standard that we are delivering. So in situations where we come on a project, first of all, we submit a project schedule. Once we've been committed to the project, we submit a project schedule. We have, based on our expertise and experience, we give stipulated timelines to deliver different things, such as there's a stipulated timeline for brief collection, for concept development, for approval drawings, for coordinating with other consultants and our co-allies that we work with on projects. All the way, we have a timeline for every project. In times of delays, what we try to do is try to see how we can plug possible areas where there could be waste of time. But the principal thing that controls the project is the availability of budget. But on projects where there's a project budget and there's an inflow of cash and the project is a continuous process, what we try to do is ensure that we follow our scheduled timelines. So whatever it is that we have to do in the studio, whatever it is that we have to send to the client, we ensure that anything that can happen now, happens now, and everything is happening according to schedule. So basically what we try to do is control the documentation and the process with our SOP, and we also ensure that we draw up a project timeline based on our experience to ensure that what can happen within a week happens within a week. What should take a month should actually take a month. And in processes where we have to catch up, sometimes we have some extra hours where we put in work. We also put in some work on the weekends depending on what is required. But the principal thing is to ensure that we keep to schedule and we keep to time, because at Building Practice, we don't only just sell quality, we also sell time. So we ensure that we try as much as possible on our project to keep our word.
So at the Building Practice, high on our priority is the client's vision. We try to materialize and put to paper what the client's vision or idea is. We try to bring that to fruition. So top of that on our priority is beyond what the client wants. When we try to do that, I also think about the users of the space, how we try to make the users feel comfortable in that space. So for features and amenities, we try to incorporate in our design, especially when we deal and execute high-rise buildings. We try as much as possible to create smart and sustainable design principles in our design. In a high-rise building, some of the principles and amenities we incorporate are smart building design. So for small buildings, we normally do home automation system, like we normally know Google Assistant, Amazon Prime and all that, try in small buildings. But with high-rise building, we use building management systems and building automation systems in our buildings. So what that effectively means is when they're designing the HVAC system, the lighting system, the electrical system in our buildings, we try as much as possible to incorporate building management systems and building management models in our design. That helps to increase efficiency in the buildings and also the overall user experience. It saves costs in terms of energy use and also energy efficiency in the buildings. The building practice here, durability is one of our watchwords. We don't just want to build and so that we have issues down the road. We try to build long term. We look at the long term picture. So the true and tried tested material is concrete. Concrete in its various forms. We look at reinforced concrete in all the various expressions of reinforced concrete. So those cast in situ, reinforced concrete in situ, pre-stressed concrete, glass fiber reinforced concrete, and reinforced concrete in its various forms. So that's one of the main materials we use for high-rise buildings. We're also trying to incorporate steel, although I've not gotten to that stage yet because steel we are looking at when we started to do skyscrapers and those taller buildings, incorporate steel in our designs. But for now, it's reinforced concrete we use it majorly. Also for the facade, we use curtain walls. So curtain walls, window for the glass, well specified in terms of the UV value, and also the curtain systems that will help protect and encase the building so that the environment in and on the outside and on the inside, there's thermal control for the users of the space. So at the building practice, one thing we also try to do is try as much as possible to design for the environment we find ourselves in. So very sad and unfortunate is the issue of the Los Angeles fire. We saw how, which is the materials they use, timber. We saw how the fire ravaged the whole city and many homes were razed down. But for we that are in the tropics, tried and trusted material, which we have advanced over the years, is use of concrete. So concrete is a very, very durable material in terms of use of high-rise buildings where we find ourselves in the country. So in Lagos, in Abuja, where we worked, downside in Port Harcourt, concrete has always been a true and tested material. And other materials we use so for the finishing, from the tiles, porcelain tiles, to the cement board, to the plaster board, to gypsum. We try to incorporate other materials, local materials, so that we don't have to import everything. Try and incorporate local materials in our buildings.
I think the key thing to balancing modern trends with functionality is to understand that buildings are predominantly meant for people and not just for show. So as architects, we are constantly thrilled and inspired and fascinated by the latest modern design trends that we often tend to sacrifice functionality for aesthetics. It is important to know that the true beauty of a building's beauty lies in how it makes people feel. We believe that a building should not only look amazing, but also help to improve people's lives and make it easier. So when we are designing a high-rise building, we constantly ask ourselves these questions. How will this building improve people's lives? How will it make their routines easier? Will it make it more enjoyable? Will it make them productive? So for instance, when we are designing a building of 45 floors, how easy is it for people with special needs to access the building? Can he get to the 30th floor with ease? In the event of an emergency, for instance, a fire outbreak, can the occupants exit the building with ease? At the building practice, when we design, we put people, the end users, at the core of our design process by incorporating design elements and key features such as ramps, escape staircases, signages, and all of that. Because we believe that by having a people-centered approach, we can create buildings that are not just visibly stunning, but also functional, sustainable, and enjoyable to inhabit. Okay, to determine that, when designing a high-rise building, we start by asking ourselves these questions. What is the building's intended purpose? Is it a high-rise residential tower? Is it a commercial office space, a mixed-use development, or a mixed-use development? Once we understand the building's purpose, we can then begin to design with that specific function in mind. For instance, when we are designing a residential tower, we often prioritize natural lighting, acoustic comfort, circulation, and a host of other factors that are necessary for residential dwelling, all in order to create a peaceful living environment. A good example would be Wuta Residences in Victoria Island. This project is an 11 floors, suspended floors with a basement. It has 36 apartments. For this particular project, we have to consider the rate of occupancy, which is 36 apartments. We had to make provision for adequate parking. We had to make provision for good circulation by incorporating elevators, main and escape staircases. We have ramps for people with special needs and some other good factors like that to enhance their living. So at the Building Practice, we very much believe that by putting people at the core of our design process, we can tailor our designs to their specific needs and support their intended purposes.
Some of the buildings that we have worked on at the Building Practice is, for example, the Glover 27 project, which is an office building. It is on 15 levels of floor slabs, and it has a 1,000 square meter of office space per each level. So that's culminating into like 15,000 square meters of office space to work with. Then you have projects like the Bloom Tower, which is a series of apartments that comes together into 125 units of a configuration of 1 bedroom, 2 bedroom, 3 bedroom units in maisonettes or in just flats. Then we now have projects like the JT Tower, which is a luxury high-rise residential unit where you're having 30 levels of floors. That's a combination of series of 4-bedroom apartments on a floor plate of 1,000 square meter each. Then you now have a very, very executive level. That's a triplex. That's combinating of 3,000 square meters for just one apartment. Along with that, we now have projects like Parkview, that's like 10-story building, and it's a series of residential apartments too. So those are some of the high-rise buildings that we have worked on our Building Practice. In order to be able to provide the kind of value that our clients truly require, from the design stage to construction stage to post-construction considerations, we make sure that every aspect of the building, every element of the building that is being provided for, that is being designed, conforms to not just the International Building Code, the IFC, also all the sustainable facilities like EDGE and LEED, because in order for the building to reach its best and provide the best value for the people that are going to use the space, we have to bring together all of these standards and conform to them. Along with that, we don't just design them to conform. We also go to the site and ensure that during installation and after installation, that the elements of the buildings, from the floor slabs to the thickness of from the thickness of the floor slab to the height of the handrail to what the door should look like to the kind of lighting you use in this space, we'll make sure that they all actually conform to all of the standards that are required for each one. Regarding mitigating against local weather conditions, based on our environment, we are in a tropical environment. Because of that, we have a lot of sunlight, we have a lot of rainfall. So most of the things we design have to be towards, adjusting for the realities of those conditions. Regarding when you have a lot of rainfall in a situation, you have to drain the water, you have to make sure that the materials that you use in your building are actually waterproof. So because of that, that brings us to waterproofing of the walls, waterproofing of the floor slab, waterproofing of the foundation. In most cases, we usually have like 2 or 3 steps level of waterproofing the slabs and waterproofing the foundation to be very sure that the water does not get through to the material. Then when you have your floor slab that is exposed to weather directly, you have floor drains in specific distances to make sure the slab is drained as quick as possible and to reduce the amount of water that's going to be flowing over the slab. Then you now have, taking from that point on, you now have designing against harsh sunlight. Now for harsh sunlight, what usually is shading. You have horizontal shading devices, you have glazed units in which you design to reduce the amount of heat transmittance into the building. Then you have air conditioning system that's supposed to help to reduce the level of heat that the building has gained, and so on. And that is how we design to mitigate the harsh realities of the local weather conditions at the building practice.